All right. So as you see, and as I have also mentioned, that this presentation, this lecture, this session is going to be on the topics of dialogue systems and question answering. So this part, so two different themes we have. One is dialogue system and is question answering. They're not completely different. There is some overlap, but they're two different problems altogether. And yes, so we'll try to cover dialogue systems in more detail. And depending on how much time it takes, we'll see to what level of depth we can go to when we take up the question answering part. Now, I am Maunendra. I am from IIT Hyderabad. I belong to the Department of Computer Science as well as the Department of AI there. And we have a lab group which is called Natural Language and Information Processing Lab, or NLIP lab. So here we work on many problems related to NLP from different layers. So it can be something which is at bit more foundational layer, where we try to address uh, how do we work with low resource languages, to something at a higher level where we try to come up with application specific algorithms or techniques. It can also be something in the middle where we try to capture some kind of insights from the data, which can be, and those techniques can be attached across many different applications. Say, for example, if we have some kind of toxicity that we want to detect. So this is not very application specific, but once we have that understanding of how an algorithm can be developed, what kind of algorithm can be developed for these kind of things, it can possibly be attached to many different end tasks or downstream tasks. So we work on problems related to multilinguality, dialogue systems, hate speech analysis, and various other problems. Okay, now enough of advertisement. Let us go to the topics now. Uh, Dialogue. Dialogue is important. I think you all would agree. So we have seen that during the COVID period where all of us were confined inside our houses, is the dialogues that we had with various people that kind of kept us alive, if we can say like that, apart from the vaccine. So it's important because we can express our thoughts, we can possibly get information and various other things. And that is why dialogue plays a major role in day-to-day life. No single human being would possibly exist without any sort of engagement in any sort of dialogues. So essentially, dialogue is a multi-way communication. It requires at least two parties. If you have more, it's even better. And then if you search for the word dialogue in Google or Bing and try to get some meanings of it, example usage of it for the word from online dictionaries, you will see that it is used in many, many different senses. Although at the core, it tries to cover the same aspect, but depending on the usage, it can mean quite a few different things. So let me give a few examples and then we'll see what is the meaning that exactly we try to attend to in this discussion. So if we see that, okay, the dialogues in the series Panchayat were amazing. So here, what does dialogue mean? The different characters, what they are talking about, and how it is progressing throughout that entire series. So that is the dialogue. Okay? And many a times this is scripted, and the role of the scriptwriter becomes very, very important here. Then we can also have something like the two countries should stop war and get into a dialogue. So here, what kind of dialogue are we talking about? Across two peace talks, yeah, coming to a consensus or a treaty. Yeah, so it's something like you have some frustrations, you have some issues, bring that to the table. Let us discuss and let us work it out to see if we can have any peaceful solution towards that, right? So that is the essence of dialogue here. And then if we have something like the dialogue with the HR went well. So here the dialogue, what could it mean? Meeting, maybe salary negotiation, maybe details about job role and other things. So the purpose of all these dialogues could be different, right? So the first one, when somebody writes a dialogue for a series, tries to make sure that the audience is engaged. right? It is either sufficiently witty, or it is somewhat like, it maintains the natural flow which aligns with the theme that the entire story is trying to project. In the second part, there's an end goal to achieve, which is to get into a peaceful solution, to iron out all the differences which exist. And the third one, it's mostly for information seeking, and then trying to see from both sides what is a ground, middle ground, or agreeable ground that can be hit. So essentially, dialogues can cover a multiple range of aspects, and a successful dialogue would be one where this goal, whatever that particular dialogue has been set out to, so that has, that is achieved. Okay. And it can be in verbal mode, like the conversation that happens during the coffee break of this session. It can also be through written language, like chat messages or email communications, and through sign languages as well. And of course, multimodality could also be considered. Through images also, one can communicate. Okay. Now, in this field, these kind of dialogues are also called conversations. And in the field of computing, in the field of NLP, so we also typically use the term conversation and dialogue in an interchangeable manner. Okay. Now, dialogues have certain characteristics, as we mentioned in the previous slide, that it requires at least two parties, and it focuses on a theme. So if there is a dialogue which is happening without any theme, it goes back and forth in a haphazard manner, that may not be a very good dialogue. Right? There are some examples of those kind of dialogues also. And what does it aim to? To understand this we talked about briefly while discussing the different meanings of dialogue. So the aim is to understand the other side better, and vice versa, make our situation understood by the other side. It can be to get some information. So maybe before joining the summer school, if you had any queries, one option was to reach out to the volunteers or the organizers to see, various things. So dialogues can also be there to get some information, and also to solve certain tasks, like you have ordered some product on an e-commerce site, and the product is being delivered on a certain day when you will not be at home. So you contact the customer care and maybe request whether it can be postponed, the delivery can be postponed, and it can be delivered the next day. So here there's a goal that, okay, I want this to be done. I want the customer care representative to help me in that, achieving that. And right, but here we're solving some tasks, but does the dialogue always go in one direction? Although there is a theme, central theme, does it always go in the one direction and convert somewhere? The answer is both yes or no. Like for getting information or solving tasks, like the e-commerce example, or for the troubleshooting kind of cases, for uh, technical kind of situations, yes, mostly it reaches a conclusion, it converges somewhere. On the other hand, if we talk about legal battles, where the theme is same, but there are two sides who are trying to put their arguments, and these arguments and a flow of thought that contradict each other. So sometimes there might be convergence, sometimes it may not converge. And then there could be some other kind of discussions, and better not to talk about that, because it is one of those haphazard communication where nobody listens to anybody and everybody loves to speak. Okay, so so far what we have covered is what is dialogue. Okay. Dialogue has two different meanings. At least two different spellings, and I believe the first spelling has a uh, so the first spelling, this one, do you see something special about that? It is one of those words that has all the 5 vowels present in it. Okay, so yeah, if the content doesn't go in, maybe that is one take home message. Yeah. So yeah, so what is dialogue and what do we expect from dialogue systems? So that we have covered. And now let us try to look at automated dialogue systems, or dialogue agents, or conversational systems. And the process to realize those can also be called conversational AI. Okay, automated dialogue systems. So what are we trying to automate? The response generation, and we hope that the responses would be like human-like. Okay, a human, how he or she would like to respond, it will mimic that behavior. That's what the expectation is. And suppose I consider this utterance from a user that I'm attending a session on dialogue systems at the ACM summer school at IIT Gandhinagar. Suppose the user says that. Now, can you give me some example responses which can come out from a dialogue system? Any volunteer? So my question is that, suppose a user says this thing, I'm attending a session on dialogue systems at the ACM summer school at IIT Gandhinagar, and the system tries to generate a response to it. What kind of responses could be generated? Sorry, say again. Okay, I hope it becomes. Thank you. Anyone else? I think there was, sorry. How was the session? Great. So that is another. Anything from here? So score 1 for this side, 1 for this side. Anyone? You can just. Who is the speaker? Okay, okay, that could also be. So all these are actually good responses because they're grounded on the uh, topic that this sentence captures, right? One can also say that, oh, don't attend it, it's a useless session. That also would be a good response because it's on the theme and it's connected well with whatever being said is being said here. But suppose somebody says, oh, Australia is out of the World T20 Championship. Is that a good response? Not in theme. Suppose somebody says, oh, you are attending, इसमें तेरा घाटा मेरा कुछ नहीं जाता. Is it good? Well, that can be the essence of the utterance, but typically it's not polite, it's not courteous. So that kind of response is also we not prefer, right? So what should we aim to achieve? What kind of traits, what kind of aspects would we like to see in the generated responses? The first one is it should be relevant to the context. Okay, arbitrary responses, no. Then it should be explainable. If somebody questions you, why did the system generate this? There should be an answer. It should be courteous. It should be grounded. So there are different meanings of the word grounding. We'll talk about that later. One meaning of grounding could be like it is aligned with the theme. And not only aligned to the theme, aligned with also the entities which are being mentioned in the utterance. And then there could be another issue, like not issue, another aspect that you should be empathetic when required. And finally, it should progress in the right direction. So what is the right direction? When we talk about the different types of dialogue systems, this part we'll try to cover. Okay. So, we've seen that dialogue systems are conversations with automated agents, and we are assuming that it takes natural language input and produces natural language output. However, there can be multimodality also included here. Then there are systems, there will be a system that provides responses to the utterances. And essentially, the entire flow of dialogue is nothing but a sequence of user utterance and system utterance pairs. User says something, typically the user initiates, and then the system responds like that user system in that manner, it will flow. And also, commonly it is termed as conversational AI. And traditional systems were rule-based or flowchart-driven. But nowadays, recent advancements in NLP has made the dialogue systems much, much more smarter. Okay, now coming to types of dialogue systems, one is goal-oriented, where the system tries to help users to complete the task through conversation. Now, it can be as simple as one shot, not one shot, single turn thing, like set that alarm at 12:30 p.m. Okay, the system knows, okay, what do I have to do? I have to set alarm. What is the time? 12:30. Does it? Done. Okay. So that's what we see on the left-hand side picture. One can also talk about, getting directions. So how do we go from point A to point B? Maybe the system tries to get that information from somewhere and says that, okay, you take a bus from here to there, from there you take an auto and you reach there like that. And it could be for booking tickets, hotel reservation, and so on. And then there are many, many such systems which are nowadays quite popular. like Siri, Alexa, Cortana, Google Now, Google Home. And do they always work? Do they always become successful? No, there could be some cases where they fail to understand. There could be cases where they fail to do the job that they're supposed to do. So one example is here. I'm not sure whether you are able to see it. It's that it says that Siri, I'm bleeding really bad. Can you call me an ambulance? Siri says, okay, from now on, I'll call you an ambulance. Okay. So it was not able to interpret the intent of the user and what was supposed to be done. So yes, there are systems, none of them are perfect. So a lot of things still need to be done to make them much more perfect and do the things that we expect them to do. Then there are quite a few data sets also which help in doing research towards the development of such kind of systems. Then there could be non-goal oriented dialogue systems also, where they try to mimic unstructured human to human conversations or chats. So it is something like you are getting into a casual conversation with somebody, like in the over a cup of coffee or during the coffee break, tea break, or something like that. You can also consider these examples to be something like uh, somebody who has gone to a counselor and having a discussion. So it's more to see how the other side is opening up, sharing thoughts, and so on. And it could also be something between two strangers, maybe at an airport where they're just there for a long amount of time and they want to explore things. So it can act as a psychotherapist, assistant, virtual friend, and so on. And there are such systems already available. ELIZA is one of the very first systems that I believe many of you have heard of. It came, when did it come? Any idea? Around which time frame? So ELIZA is the first chatbot that was developed by MIT. In 60s, around 1965, it came. And then there are others as well. And there are different data sets also, which help to do research for this kind of non-goal oriented or open domain or casual conversation or chit-chat type of dialogues. Okay. So then, well, I'm not sure whether it is very much visible or not. So I'll show one conversation between a human travel agent and a human client. The client says, I need to travel in May. The system says, and what day in May did you want to travel? Is trying to get some more information, which is helpful for solving the end task, which is the ticket booking. So the date needs to be obtained. So it says, what day in May did you want to travel? Okay, I need to be there for a meeting that's from the June 12th to June 15th to 15th. So you see the conversation is there. It is not directly giving the desired answer. So this 12th to 15th, what is the month is not directly mentioned here. You need to get it from the previous utterance. So it is 12th May to 15th May. But it also says I need to be there for the meeting which is planned in this duration. It still does not give you the exact date of the travel, right? So the system will try to get that information. But in the meantime, it is asking, and you are flying into what city? Seattle. And what time would you like to leave Pittsburgh? So maybe the conversation before had some indication that the user is traveling from Pittsburgh. So what are the things that you need for making a travel booking? One is source, one is destination, then the date. Anything else? Time, yes. What else? Mode of traveling, names, anything else? Maybe if there are any preferences, even there, if there are multiple choice, okay, I do not prefer these airlines, okay? Or things like, I want an aisle seat. So all these things come into picture. And there are some things which are optional, like seat preference, but there are certain things which are compulsory, like the dates. So it tries to get all those information. If you go through the next few utterances, you will see that at what time would you like to leave Petersburg? I don't think there are many options for non-stop. So that means indirectly it is talking about the preference that I want non-stop flights. Says, right, there's 3 non-stops today. What are they? Then it gives the details and so on. So what do we see here? Firstly, it is progressing towards the goal. Step by step, it is trying to gain more information, trying to fill in the missing slots so that finally the booking can be done. Then we see that it has been courteous throughout. Hmm. The way the answers are coming, it's kind of soothing and a bit polite. And at the same time, there is explicit grounding in the response. So what does this mean? That uh, so when it says what day in May you want to travel, so it mentioned the word May here. So it could have said that, okay, what day did you want to travel? But it is using the word May to give an indication that I have understood you, I have heard you. So it kind of instills a confidence in the user that, okay, my conversation is going in the right direction. Later on also, you'll see that there are many such examples. Okay, I'll take the 5-ish flight on the night before on the 11th. On the 11th, okay, and like that. So this is another example of grounding. You identify the entities in the conversation, and whenever it is appropriate, you include that in your response so that the other side knows, other side is confident that your messages are reaching the agent, and accordingly the thing is being done. But sometimes, many times we have seen that the agents overdo it, and that becomes annoying, right? So there is a fine balance, and these balance, hopefully, these AI kind of solutions or machine learning or deep learning kind of solutions would be able to achieve. All right. So any questions so far? Okay. So far, what we have seen, that what is a dialogue? What are expectations from dialogue systems? Yes. Mostly same. So whenever we talk about chatbot, typically uh, it will be like, so we have this goal oriented and non-goal oriented, right? So chit chat will be chatbot, and goal oriented. So that could be like what we do with Alexa, play this song. That will not be chatbot. And chatbots inherently will assume that there will be multiple turns in this conversation. But there could be scenarios where even only one instruction or instructions are enough. So typically, that will not be a chatbot. Okay. So we looked at introduction to automated dialogue systems. What are the types of such systems and some examples, and some desirable properties for these systems. Now, as we mentioned, the main goal of dialogue systems is to produce some response in an automated manner, right? So what could be the generation strategies? What could be the response generation strategies for dialogue systems? That is something that we would like to look into now. Okay, so the dialogue systems, this response generation can be done in many different ways. The first one is retrieval based. So here what happens is that uh, you have a pool of responses already available with you. Hmm? So, and how many responses? It depends on the usage. And then you look at the dialogue context and identify the response which matches this scenario the best. Okay. So how would you do that? One technique would be like that, okay, whatever context or whatever utterance you have for the current time step, that you encode and get a vector representation out of it. At the same time, you can use the same mechanism to get the vector representation for all the utterances or all the possible responses which are there in the system. Now, since the list of responses, the pool of responses is already designed, already curated, this can be pre-computed, these vectors can be pre-computed and saved. Now your task boils down to encoding the input as a vector and finding out the similarity of this vector with the possible response vectors. And the one which has the highest similarity, that can be output as the response. Okay. So it appears to be simple. And one thing is that it often matches at the template level, right? So if you look at the different entities, I would like to leave from Pittsburgh. And the response is, when do you like to leave Pittsburgh? Now, suppose there is some other airport name which is coming and that is not there in the pool. Like, I want to leave from Bangalore, and suppose Bangalore is not there, due to which the sentences are far apart, and you end up picking some other response like, when do you want to reach Bangalore? Right? So definitely it's not the right thing to do. So many times for these kind of systems, they replace the actual occurrences of entity names with their entity types, and this thing goes into the database from which the responses are picked. So often matches happen at this template level, and at the same time it is data intensive. So if you want to have a very good coverage of your dialog system, you need to ensure that you are able to configure all different kind of responses that you should be able to generate. And that's not very straightforward. And the other thing is that it sometimes may become monotonous. If there is a system which is coming to if there is a user who is coming to the same system again and again and sees that, okay, same kind of responses are being given, uh, it's it's not very it's not a very great experience. It can become monotonous. Uh, so many times we can see, you go to a doctor, and even before you meet the doctor, the receptionist says, "No, sir, the doctor is full," or "No, he will come back after some time." And irrespective of how many times, in how many ways you can ask same question or different question, it comes down to the same response. It becomes super annoying. So we do not want the systems to behave in that way. So due to which people try to slowly shift from this retrieval-based mechanisms to other kind of mechanisms. Yes. Yeah, that's a very good question. And one point I forgot to mention earlier. So dialogue system or this response generation is a difficult task due to two main reasons. One is that the finally what you come or what you generate should be a proper, I mean, the information should be proper, grammar should be proper, and generating grammatically correct sentence is very difficult. That's one reason. And the second reason is that it's a one-to-many kind of system. For the same input, there can be so many different types of output, and each of them could be equally valid for the response. So this is where, if there are many responses which are equally valid or very good, which one do you pick? So there also, the systems would employ some strategy to identify. So sometimes they can have a combination of relevance plus diversity kind of score. Sometimes it can have some other kind of additional signals, like there are some slides on reinforcement learning based response generation. I'm not sure whether I'll be able to spend time on that, but one point is that if you look at the different responses that you have generated earlier for the same user, suppose the previous response was hi minus 1, current response vector is hi, you try to ensure how different are this hi minus 1 and hi. So similarity becomes one aspect. This kind of consecutive, I don't know, distance between consecutive responses, this becomes another subscore. There could be other things like the readability score using some metric, and you can stitch together multiple subscores and finally pick one. That typically people would try to have some weighted aggregation of weights will be learned. Yeah. Any other question? So it's kind of simple to understand how do we get the vectors and identify their similarities. You can simply assume that, okay, we are using BERT. So for the context, you get the BERT representation. For the vectors also, suppose, for the responses also, suppose the BERT representations are there. You match, you get the scores and take the top. That's a greedy approach. But as I mentioned, this greedy score or this matching score, you can augment with several other scores and finally take a weighted aggregation or something of that sort. Okay, now this retrieval-based response will ensure that will produce grammatically correct responses. Uh, On the other hand, it becomes monotonous. So people said nowadays we can generate natural language sentences so beautifully. So why can't we use that? So here, yes, we can use language models or encoder decoder models or only decoder based models to generate the responses given the dialog context. So if you are having an encoder decoder based model, how does it look like? So suppose you have a source sentence and which has source sentence, or when I am saying sentence, the sentence may also contain the complete context. So suppose one turn of user 0, system 0, that is over. The next turn user 1, system 1, that is also over. Now the user is saying something, that is U2. So this entire thing, S0, U0, S1, U1, no, U0, S0, U1, S1, then U2, this entire thing can actually go into the encoder side. And suppose this entire thing has this X1 to XM. These are the tokens there. So this can go into the encoder side of this encoder decoder model. And this encoder stack will finally generate a vector for this entire conversation that it has seen. Now this one will be fed as the initial token to the decoder. Now the decoder will start emitting one token after the other. And suppose those generated tokens are xm plus 1 to xn. So this is what is happening. So you have the encoder, all the entire context, including the current utterance that you feed to it. And this encoder will get one representation for that entire context. And that representation goes to the decoder and with a start symbol. And now the decoder starts emitting the tokens one after the other. Right. So the other way would be like this entire thing you give to a GPT kind of system. So GPT will not have encoders. It only will have the decoder layers. Series of decoder layers will be there. You pass it on, and then so GPT will have many different possible. I mean, it can be done. The output of GPT can be used for many different things. So here we are working on the text prediction part. So first token it will predict, second token it will predict, and in that sequence it will be done. So the generation will be conditioned on the source as well as the parameters of this decoder. And you can actually have a kind of objective function here. So for m plus 1 to n, so this part you are trying to generate. So what is the probability that you generate m plus 1 based on x1 to xm? It is this one. So where n is equal to m plus 1, for your context, you are having only x1 to xm, right? So what is the probability of that? Next, you have generated m plus 1. You are going to generate xm plus 2. So n becomes m plus 2, n minus 1 becomes m plus 1. So that means this entire source sentence and the first word that you have generated, conditioned on that, you generate the next one. And in that manner, it's the typical language modeling objective that can be followed here to get the generation. Okay, any questions here? Yes. All the all the words which are generated. Not independent in this sense because so it's a chain rule for probability. We're not assuming independence here. It will be applicable everywhere. So suppose you have suppose I want to generate the suppose there is a sentence for which I want to predict the probability. So x1, x2, x3 are the three words. So we are trying to get the probability of this one, right? And this we can write as probability of x1, probability of x2 given x1, and probability of x3 given x1, x2, right? If it was independent, we would have written this as probability x1, probability of x2, probability of x3. That means x2 can I mean, this probability is same irrespective of what is the previous word. That's why you can drop it from here. But here we're not doing that. That is actually going into something. Yeah. Okay. So what are the problems with it? The problem is that although, I mean, such kind of models can generate things, it may be irrelevant at times. In fact, there are many situations where people have shown in papers that whatever the model is generating may not be truthful, may not be grounded on the actual input context. So it may be irrelevant. It may also contain grammatical as well as factual inconsistencies. Right? So this is something that one is to take care of or be aware of. So if there could be some kind of post-processing on the generated response, that could be there. Otherwise, whatever post-processing you are trying to do, if that can be somehow blended into objective function and you train the system accordingly, maybe you will get better responses. But again, it's not guaranteed that you will be getting the perfect answer all the time. Yes. Mhm. Uh, see. Hmm. Right. So by default, it will not work like that. I mean, it will try to find the different association and probabilities coming from that. And then finally, when it selects the words, there it could readily pick one word. Otherwise, there are different sampling techniques like top K, top P, the sampling techniques are there. So chances are there that something else will be picked up. We cannot guarantee, but many of the systems they have, there is a concept called pointer generator network. So if there are some entities which are being predicted at the next time, it will try to pick entity or copy entities from the input. So there is one probability for copying, like that probability is P, and probability 1 minus P is for generating. So it will firstly try to see whether I need to copy something. If that probability is high, it will try to copy the relevant thing from here. So many times this pointer generator thing could be helpful there. Secondly, we'll talk about that. There is something called delexicalization. So where instead of predicting the Seattle or Bangalore or Pittsburgh, it will predict the entity type, like the start airport. And once this is generated, it will fill in the values that it will try extracting at the background. And that way it will be more grounded. Okay. Yeah. Any other questions? Okay. So here is one example that user said, I finally got promoted today at work. System says, congrats, that's great. And user says, thank you, I have been trying to get it for a while now. So this entire context, I mean, this one, I mean, these are some special tokens, and there could be some separators in between. It depends on the design. So this entire thing goes into the encoder. Encoder then, I mean, this decoder then generates this one. Okay, yeah. Uh, can you use for what? Goal oriented. Yes, yes, you can do that. You can do that. There are, so I mean, there are some, I don't recall the exact numbers here, but many times where people use, I mentioned some data set names, right? When we are talking about, people run their experiments on that, they report the values, and they don't actually talk about the accuracy, but there are different other metrics like blue, meteor, roach. According to that, they give the scores. And for blue score, I think, again, blue has blue 1, 2, 3, 4. I think around 30 or 40 people consider it to be a good score. And there are systems which have been achieving those consistently. Then there are some metrics like perplexity and other things. So it's not only one metric, people try to look at different metrics. Okay, now can we combine both these words, the retrieval word as well as the generation word? So nowadays when people are talking about RAG, retrieval augmented generation, essentially they're doing the same thing, but the scale at which they do, how the generation happens. So here, I mean, things may differ. So what happens is that, again, I believe this is small to read. So it generates response from informative text rather than dialogue. So what does it mean? So when we talk about the encoder decoder kind of architecture, we said that the entire context can be given as input. But that means you are trying to generate something from the dialogue which is happening now, and based on your knowledge about the world, that is encoded in the parameter somehow. You're not referring to anything else. So you went somewhere, you joined a course, you got some understanding of some things. Now you're sitting here, you have closed your, I mean, you're not gaining any new knowledge from anywhere. You're just looking at what is being told, and based on whatever you have learned, based on that only you are trying to predict. However, at the same time, many times in a conversation, we say that, okay, we'll check and get back, right? It's that we'll check and get back. So based on whatever has been told to you, you try to get some additional information, additional knowledge, additional input from somewhere. And based on that additional input and what is the current context at hand, you try to generate the response. So one example that was mentioned in one paper is that, tell me something about Beijing. Now the system may not have information about Beijing at its fingertips. So retrieval based is very difficult. Then generation based, it may generate something, but the entire, if the system is trained on a large volume of documents, inside the parameters, it might be a mix of all different kinds of knowledge. And then suddenly, if it has to say certain things about Beijing, it will say things, but it may miss out certain things. It may also mention something which is not specifically about Beijing. So that risk is there. So to narrow down the context from which it has to say, and at the same time, to give sufficiently good coverage, this kind of methods could be useful. So in some sense, if we can talk about precision and recall of the information, it's difficult to just quantify based on this statement. Somehow it tries to strike that balance, that not balance, but it tries to achieve that precise responses as well as good coverage. So it collects the sentences from public lectures and articles. So it's one Microsoft system from which this is coming. It searches them using IR. What is IR? Information retrieval based query expansion from the user's turn. So user has said something. So based on that, it can identify keywords and it can do a query expansion. So along with the keywords, it can also expand the list of keywords. So Beijing is in China. So this China may also come, and a few other things may also come. So based on that, it formulates a query and then it searches from a larger repository. What is that repository? That can be anything. It can be the entire web. It can be a restricted part of the web. It can be your own private collection as well. And based on that, it collects the sentences. So it can, now here also there are many different things that could be done. So when we talk about question answering, we may talk about this, that it can collect the entire document. It can retrieve the entire document. It can also retrieve the passages from the document. It can also retrieve the sentences from the document. So it can be done at different granularities. So what granularity the system wants to work at, it's up to the system designer. And of course, it has to be decided based on a lot of experiments only. So these kind of sentences are there. And yeah, so here it says, suggest an expensive restaurant that is in the south section of the city. I don't know who searches for expensive restaurant, maybe trying to impress somebody. And then the system says, do you have a cuisine preference? The user says, no, I don't care about the type of cuisine. Also, could you make the price range moderate? Okay, now it has changed. Right? So now the system knows that we want to talk about a restaurant that is in the south section of the city, and it is moderate price range. Now, the system may not have this information directly with it based on all the documents. So it may, instead of searching in a document collection, it can also search in a knowledge base, a database kind of thing. And whatever the database returns, based on that, it can generate something. And the system says may have their phone number. Now, if it already has that phone number when it extracted that record, it can use it, or it can make a fresh call to get the phone number and do it. So many goal-oriented dialogue systems actually work in this manner. They try to get the complete information needed to generate the response. And once that information is obtained, it queries a database, which is nothing but retrieval, but from a structured content repository, and context and those retrieved entities or objects or whatever. These two things together finally determine how the output is going to be. And that happens through a generative process like a GPT or a decoder stack or an encoder decoder stack. So this is essentially the same thing, but just yeah, I mean, expands the process which is there. So dialogue context based on that knowledge turn direction. It also identifies the domain, the entity, the knowledge. So everything together, how that matching happens, so that they have tried to capture. And here they have assumed unstructured knowledge base. So this is a work from Microsoft. So this I have already covered. I'll share the slides where these references names will be present. Okay, so far, what have we seen? The generation strategies in a dialogue system. Mainly, we talked about three different strategies. What are those three? Retrieval, generation, and retrieval plus generation, right? Okay. All right. Now, so this, I'll not go through this entire conversation, but what it tries to show is that if you look at the lifetime or the duration of a chat, especially for, I mean, it can happen for goal-oriented and non-goal-oriented, you will see that there are certain events which are happening in that entire conversation. At the very beginning, so here they have said that the user says, let's chat. And system says, hi, this is an Alexa price social bot. I'd love to get to know you a bit better before we chat. Is it all right if I ask your name? So they marked this as an action of launch. It's launching a conversation. Okay. Then the user says, my name is Chris. Bot says, well, it's nice to meet you, Chris. I'm excited to chat you today. And I hope your afternoon is going well. What are your plans for the rest of the day? So a chat is now initiating from this point, a specific direction it is giving now. Then user says, hang out with my friends. What? That sounds great. I love spending time with friends. What will you do together? So again, trying to extract some information from the user. User says, maybe watch a movie. Bot says, me too. I love watching movies. I get to learn so much about what the world is like outside the cloud. Have you seen any movies recently? Now it is talking about movies. So if you look at the conversation happening so far, so it launched something, it gathered some information from the user, then it has switched to one specific direction, which is the movies. And there it says, I saw the Matrix. Bot says, nice. Did you like the Matrix? Still continuing on that movie domain. And it says, I loved it. Neo is amazing. Oh yeah, I agree. Hey, isn't Keanu Reeves in that movie? And like that. And then the user says, I want to talk about something else. So throughout, initially we saw a launch, then neural chat, which is happening with initiation of the chat intent. Then it's understand the domain. So all these things are crucial in steering the conversation in the right direction. Then there is something called entity linker and entity tagger. So what is that entity linker? So what are the specific entities which are being talked about? Here it was the movie Matrix. And tracker means throughout, I mean, it says that, okay, discussion is continuing on that topic. And if suddenly a new entity comes in, like Keanu Reeves came, so another new entity comes in. So entity tracker and entity linker will be important. And then when the user says, I want to talk about something else, now that's a navigational intent that I want to change the topic of the conversation. And the current entities, everything is flushed. And a new, these objects are initialized to, again, new values, null values, default values, whatever, and they'll be populated and the conversation will grow. So internally, it's not simply as take the context, give to the GPT, and get the response. There are so many different things which happen behind the scene to ensure that the conversation proceeds in the right direction. Okay, so what are those components in a dialogue system? So modern goal-oriented dialogue systems, we'll talk about non-goal-oriented as well. We give some examples like setting alarm, flight booking, hotel reservation. So they need to they need to know certain things before performing the task. And these required information fields are called frames or slots. So for flight booking, the slots or the slots could be like the origin, the destination, number of passengers, and all those things. And as we mentioned, some of those can be optional, some might be compulsory. And these slots could hold values, and the system should get these slot value pairs before performing the task. Sometimes the user will proactively tell those. And if the user does not tell those, then the system has to identify that, okay, this is missing and this is crucial. So it will ask. So there the dialogue policy or dialogue act comes into picture. That will be another component. We'll talk about that as well. So how does it get the slot value pairs? It can identify from the utterances, or it will ask the user if it is not already mentioned. And the set of slot value pairs for the dialogue, those are called a dialogue state or frame. Now, initially when people started developing these kind of systems, there were dialogue systems which focused on specific domains, like dialogue system for taxi booking, dialogue systems for airlines reservation, dialogue system for hotel reservation. But then if you look at the hospitality sector or the Make My Trip, Yatra kind of sites, they offer many such things, right? They offer taxi, they offer airlines booking, they also offer hotel reservation and so on. There could be certain things, could be packages also. So if those kind of systems are trying to offer this kind of solutions through conversational AI, I mean, these domains can shift from taxi to flight to hotel. So the set of slot value pairs that the user is talking about is based on the user's current intent and the domain. All right. So this entire collection of the slot value pairs which are being mentioned along with the domain, that entire thing is called dialogue state. And the system has to track that dialogue state. So dialogue state tracking is crucial for goal-oriented dialogue systems. And dialogue states depend on the intent. And it's a natural language understanding task. So we are trying to identify what are the slots and what are the values. So we're not trying to generate anything. So it's not natural language generation, but understanding. But this understanding also can sometimes be modeled as a generation. We may talk about that later. And yes, identifying the slot value is not always straightforward. We'll see some examples for that. And I think we saw some examples like in that conversation, right? The system was asking, when do you want to travel? The user said the event is between 11th and 15th. And then the month information had to be obtained from somewhere. And the system also had to know that it's not the travel date. It's some range of the event and the user has to. So it's not always very easy. Okay, now a dialogue state architecture for these kind of goal-oriented systems will contain these things like dialogue state tracker. It keeps track of the overall dialogue act. Then dialogue policy, which decides what dialogue act to generate. And then the generation happens. So this is one flow. Here we are assuming that the user is using a voice interface or a speech interface, but there could be systems where the user can simply type, right? So if there is a speech interface, then we do an automatic speech recognition to get the transcript of the speech. And suppose the user says, please find me an expensive place to dine on the south side of the town. So from here, the dialogue state tracker will identify the domain as restaurant. That's the very first thing to determine. Then it will check what is the dialog act inform. So I have to inform the user of some choices. And what are the different slots? Price is a slot for which the value is expensive, and area is a slot for which the value is south. Now it can make a database query or something, and it has possibly identified some food choices like Chinese, Indian, or Mexican. So it sees that, okay, those kind of things I need to have. If I have it, I can make better suggestions. So these things, and it asks the user to select one of those. So sure, we have Chinese, Indian, or Mexican that you could choose from. So this happens. So the dialog policy says, okay, you ask the user to select among these different food choices. And based on this input, the NLG part actually generates this response, which then goes to the system. So there are three major components that we are talking about. One is the dialog state tracker. Second is dialog policy determiner. And then the natural language uh, generation. So there could be some smaller components also inside dialog state tracker that will come evident in the next few slides. Any questions till now? Hmm. Hmm. Mhm. Mhm. Right. So it's there in after a couple of slides. Hmm. Okay. Anything else? Okay. So if we talk about the domain and intent understanding, possibly it's the simplest thing in that entire pipeline architecture. So whether the domain is a taxi or restaurant or flight and so on. So understanding that is simpler, and classifiers can be trained. These are very high level domains, and there are not many such domains which are available. So there is less confusion also to some extent among these classification decisions. So classifiers can be used to identify, and based on domain, the intent can be understood. So domain is, say, flight, or domain is, say, transport, and the intent could be like finding a flight. It can be one intent. Then one can actually search for a route, or is there a petrol pump between these two? So finding a point of interest. So these all can be the intents. Although the domain can be travel, but there could be different intents inside that domain. So these are easy to understand. And there could be techniques which have joint understanding or joint extraction of domain and intent. So the next slide will possibly have one architecture for that. No, the next slide has. So dialog state tracking we have mentioned, and we have also given some examples of slot. So I'll not reiterate over this. Now this is one, that slot filling using contextual embedding. So this will possibly address your question as well. So suppose the user says, something, San Francisco on Monday. I want to depart from San Francisco on Monday. And then there is an end of sentence. So this entire thing, you can pass through a BERT or any such sentence encoder. And what will it give? It will give a representation, vector representation for each token, right? Now, based on this token, you can pass it to another classifier, which will identify whether it is inside a slot value pair or not. So the price, so it will predict whether expensive restaurant is also a part of the price field or not. So this is essentially a sequence labeling task. Sequence level will fail in this case in many scenarios. We'll come to examples of that. But suppose you have some slots and you can now have a BIO encoding scheme. I'm not sure whether you have heard of BIO encoding scheme. So it says, suppose, so entity extraction, nominated extraction makes use of this quite often. Suppose you want to extract whether something is a name or a place. Let us keep it simple and to these things only. And as you see that San Francisco, the place name spans across two different words. Or if you have some names will have the first name, may have middle name, may have been name, surname. So the names can be one word, two word, three word, and so on. So for each token, it will try to predict whether it is beginning of a name, inside a name, beginning of a place, inside a place, or outside. So these will become the different class levels. So if you have So I'm sure you are not able to see it from the back, right? So what I've written is that suggest me a super expensive restaurant in the southern part of the city. Hmm. Now this thing goes through that BERT encoder. It's the natural language understanding part. So we can work with only the encoder side. So it will now give a vector representation for each of the tokens. Now, let me just use the terms token and word interchangeably. In vector for the, vector for southern, vector for part of the city. And each of these vectors can actually be passed through some kind of network where there'll be a softmax layer in the end, where it can give something like beginning of restaurant name, inside of restaurant name, begin of price category, inside price category, and several other things for other slot value pairs and O. So if the system, such kind of systems will need to be trained with this kind of data, and it should now be hopefully able to identify that super expensive or super expensive restaurant is the price category, southern part of the city is the location, and so on. Now, one more thing would be needed here is that normalization. The southern part of the city is very verbose way of saying something. Essentially, it may mean south. So in the database, when we record the things, possibly we'll only store south or something like that. So that normalization also will come after this extraction so that we can have a suitable database match. Otherwise, if it is completely unstructured, then based on, again, vector similarity, we should be able to pick. But for this part, we need a training. Okay. All right. So it can do the domain. So does it answer your question? Okay. So it can do the domain and intent. It can get the domain and intent two together, and like airline travel plus search flight. Airline travel is the domain, search flight is the intent. Point is that these are local decisions. Whatever decisions we are making is based on what we see here. So we can say that, okay, the previous context can also be embedded, and then we are doing a prediction of this, but it's inherently local. Whatever input is given, based on that only it is trying to figure out. If there are references to something else which is mentioned at the very beginning, then this method will fail. And it's large number of classes. So typically there will be many domains and slots. So essentially, if there are m domains, and on an average, each domain has n slots, so total m into n classes will be there. And along with that, you have the begin and inside to 2 into n classes plus 1 outside, 2n plus 1. Sorry, 2mn plus 1. It can be a large number of classes. So this may become difficult, and then you need to relearn this thing for new domains and new classes. So this is some inherent difficulties with using these kind of systems. So there should be some better ways of achieving it. So this is one such approach. It is one of our work that we did. So Mm. Yeah. So can you help me find some attractions in the east part of the town? So the system identifies that the user is trying to identify, get some attraction, and the area is the domain is attraction, slot is area, value is east. Definitely, my favorite place in the east is the Funky Fun House. It's funky and fun. Can I have the number, please? So this thing remained. So this belief state or dialog state is actually cumulative in nature. So this attraction area is, it is already there and the dialogue is continuing and a new thing is coming up. That is for the attraction, the name is Funky Fun House. So it got accumulated. Then the system gives the responses and says, do you need anything else? Yeah, I need a restaurant. They need to serve Indian food and be in the same area as Funky Fun House. Do you see a problem here? Same area. Which area? It doesn't explicitly mention. It's referencing, right? So attraction is area east. So this is still live. Attraction name is Funky Fun House. That is also live because the user has not, I mean, and that slot is still active. It's not flushed. Then restaurant area is east. How do we get that? Because the same area where this attraction is there and that attraction is there in the east part. So that value is copied. And then restaurant 4 inside. And finally, some other, I mean, the conversation proceeds. So, so yeah, how do we handle this? So this is one thing that we did is that, so the now, as we mentioned initially, when the such kind of chatbots were introduced, they were targeting specific domains, but now same thing is actually catering to multiple different domains. At the very beginning, we check whether the domain has changed or not. For the very first utterance, domain will always change. We are talking about a new domain. And the system, so based on this, you say, firstly, we have a classification task where it's a ternary classifier. There are 3 classes. First one says it's a general conversation. No domain is being talked about. Like, thank you, goodbye, hello, I need some help from you. So these are some general conversation where we do not have any domain. Then the other 2 classes are, there's a domain change. So previously there was some domain, we're talking about a new domain. Like, okay, now I want to find a restaurant. So that's the domain change. Very first thing, I want you to book a restaurant for me, is again a new domain. Otherwise, if it is, there is no domain change, then we can go to the next part. Or if there is a domain change, first thing we'll do is predict the domain. That's a classification task. Now you predict the slot action for each of these current domains. It's slots of the current domains. Now it is, if it is restaurant, we need to get the name or the location or the price range and things like that. Now these slots, which slots will be active now, is conditioned on the domain that it is. So now that we know the domain, we can activate those slots and we check the different slot actions. What are the slot actions? One is 0. That is, this slot is not relevant here. One is 1. So we need to request for that value. Then value is yes, no. So there could be some yes, no kind of responses also. Then this is says the value resides in this user T. So whatever the user says, in that the value is there. For example, I want a restaurant in the southern part of the city. So the value of the slot that is present in the user utterance. It could be something like the value is in the system's response. Like the system said, okay, there is this restaurant XYZ, which is there in the city. Would you like to book? Yes, please book. Now the slot information is not in the user's response, but in the system's response. And the last one is, it is there in some earlier utterance, like in the same area as that one. I want to travel. I want to come back on the next day. But what is the previous day? That is there something somewhere else. So these are referring to earlier slot. So the typical entity tagger, what we showed earlier, will not be able to handle this kind of scenarios. And yeah, so the other thing is that entity annotation based scheme, it needs to be retrained whenever you have new slot, new dialog, new domain, new actions. So we can expect more slot values in the future. So many of the systems, many of the organizations, they are setting up their conversational search engines now, and they'll expand. Possibly, we should not tell them to throw away all the learned models, right? So we should approach the problem in such a way that there is a provision of incorporating these newer slots or newer domains anytime. So for multi-class so we expect more slot values in the future. So flat multi-class classification becomes unreliable, and we want to break the entire task into multiple pieces now, smaller pieces. So firstly, domain change. Yes, and it's a small piece, and then it needs to be extensible. So what we do is, for this slot value extraction, I'll come to the main point. This domain slot identification value, we convert it to a question answering part. Okay, for the restaurant, if we want to the location, so instead of creating a classifier for restaurant location, we said which location do you want your restaurant to be in? And there are many good models for question answering which can be utilized for this task. In fact, when we talk about prompting now, it is so we do something similar. We ask the model to give out the specific answer that we are looking at. So this we did earlier, but the same concept is now coming as prompting. So this identification part, this classification task, we translate or we convert it into a question answering task. And we make use of the many good quality question answering kind of data sets, which are pre-trained, right? We do not need to train ourselves also. So that is what we do. And right, so it was one example. I'll not go through the example, but essentially the output of the different stages for the slot value determination could be here. Like for the different terms, is there a domain change? If yes, predict the domain. And domain slot pair also you pick. And what is the slot value? A slot action. Like the value here, it was like the value resides in the user utterance. So now you have a question answering this kind of task where the passage is the user utterance and the question is which part of the town, and it will give the answer. So that is the slot value. The next, when it comes, you check whether it is domain change. No. So you need not classify the domain. You need not identify what slot values I want to have. That means you do not have to have a large classification task on a large number of classes. You stick to your that domain and have a question like, what is the name of the attraction? It says that 6, which is in the system's response. So you give the system's response and the question, you extract the value. So like that. And what is the good thing about this entire process? Anytime, suppose the user says that, oh, why did you say this? I didn't want. I said something else. You can actually trace back and see where the thing has gone wrong. So somehow it becomes explainable or interpretable in nature. Okay, so I'll proceed to the next part. So we have understood the slot value identification part, but identifying the slot value, after that, we need to generate a dialog, right? So here the dialog act comes into picture. So a simple dialog act could be hello, that is a greetings thing. The user says, hi, I'm looking for somewhere to eat. The user will, the system dialog act will now be hello. And it will also understand that the user is trying to find a restaurant. So the system will generate this kind of response. So dialog act determination will identify this as the act. Subsequently, the generation part will generate this response. Now, the system says you are looking for a restaurant. What type of food you like? So like an Italian somewhere near the museum. And the system now has to inform that, okay, for food, Italian food, which is near the museum. And like that, it will proceed. So there are many different dialog acts like hello, A equal to X, B equal to Y, then inform A equal to X. So system says, okay, there is a restaurant with this name. So here name is A and actual value of the name is X. So it is the A is the slot, X is the value, B is another slot, Y is the value. That could be request because some missing value it tries to get. Then request alternative with A equal to X. The system, the user asked something the system didn't get, but is suggesting some alternative. And then explicit confirmation, implicit confirmation, and all that. Deny, no, it is not that is not possible. And all these things are possible here. So dialog act, dialog policy, these are sometimes intertwined into the same thing. So some kind of dialog policies that people also mention are confirmation or rejection. So what is confirmation? Say, which city do you want to live from? Baltimore. And the system says, do you want to live from Baltimore? Confirming. So this can be also one dialog policy that apart from the acts, you can confirm this one. And I'd like to fly from Denver, Colorado to New York City on September 21st in the morning on United Airlines. Let's see then. I have you going from Denver, Colorado to New York on September 21st. Is that correct? So this is some explicit confirmation that the system is asking for. Then there could be some implicit confirmation like, I want to travel to Berlin. When do you want to travel to Berlin? So it's not directly asking, do you really want to travel to Berlin? But in its response, it has blended that. And if that was incorrect, the user would say, so it's some implicit confirmation. So, hi, I'd like to fly to Seattle Tuesday morning. So traveling to Seattle on Tuesday, August 11th in the morning, your full name. So it has said this, but then asking your full name. If the user just proceeds with the full name, that means the system is implicitly confirming that I have extracted the correct values. Okay, so this is how it is modeled inside the network, is that A1, U1. So here it is agent and user, like that notation is there. So based on the complete context, A1, U1 to AI minus 1, U minus 1, the agent will have to generate a response. So this thing can go into as the input of the model, and you generate the act, which is the most probable. And yeah, so that you do here. And the other thing is that you need not give that entire conversation if you're talking about goal-oriented system. For A1, U1 to AI minus 1, I mean, A minus 2, UI minus 2, this entire thing, you can assume that you have summarized sufficiently enough in the slot value architecture. So that entire frame or entire slot value dialog state can be given as input. And along with that, the current utterance could be there. So instead of giving that complete dialog context, you have the summarized form in the form of dialog state and the current utterances to get the generation. Okay. So that is the dialog act. Yes. No classifier. Yeah. Mhm. Intent is extracted at the beginning. That what the user tries to do, based on that, the slot values become active. So intent is whether booking a flight or canceling a flight, or something else. Is there some taxi that I can get? So that happens at the beginning using the contextual representation of the input. It is not keyword based. Yeah. Yeah. Yes. So there are these kind of things that people also are talking about now. The no domain being present, that is there. I mean, that can be triggered as one class, no domain. Multiple. So here, instead of having a multi-class classification, you have it as a multi-level classification. Right? There are different outputs which are possible, and more than one outputs are also possible. So that's a multi-level. So it can be taxi as well as hotel. Yeah, and then the system will try to respond one by one, or I mean, dialog acts will be done accordingly. Say, I want to book a taxi for a hotel. So suppose both the things are there. The system said, okay, so there are some hotels around this place. Would you like to book? So like that, it will proceed. The dialog act will, I mean, how it is trained, based on that, it will be determined. So, yes, those responses will come automatically. But typically, you'd not expect more than two, or in some rare cases, more than some three. Not more than that. Not more than these many domains will be active in a conversation. And all the information which for the slots, those are typically requested in incremental manner. So too much information at one go may become confusing for both sides. I mean, most of the systems are trained in that manner also. If you look at the data. Yeah. Uh, I'm not sure whether that's a drawback, or that's the way the system designers choose to design, because too much information may become confusing. I mean, certain things may be missed out, or if you mention 10 different entities and one of them is wrong, pinpointing which one is wrong and how to correct it, that also becomes a little cumbersome. Yes. Yeah. So there are two ways to look at it. The context will keep getting increased in a cumulative manner, right? So U0 S0, next time you pass U0 S0 S1, next time you pass U0 S0 S U1 S1 S2. In incremental manner, things are getting appended, you are feeding everything. So like that you can do. And you can hope that the self-attention part, or there is some attention mechanism which tries to align the representations in such a way that the most recent conversation or most recent assurances and whatever depends on that. So those get picked up. So that is something you are hoping, hoping that the system will take care of. The other way could be like, if your dialogue really goes very long, and based on the current utterance, you first have a model to identify what are the most relevant utterances for my answering my current query. And then when you pass to the actual encoder decoder, you pass your current utterance and those relevant responses, and then it should be able to generate. Right. So that is a problem due to which for a large dialogue, this entire conversation passing to it is not a very good idea, even if the limits allow you. Hmm. So yeah, every time. So that is true. That's a valid observation. People work on that. People try to see whether there is a way to represent this entire dialogue context using some vector, and along with the current utterance and I think, can we pass this vector which somehow captures the summary, and instead of passing that entire response. Yeah. Anything else? Okay. So next, this is something that we mentioned earlier. We'll just briefly touch upon this part. It's called sentence realization, uh, which has two parts: content planning and response generation. So suppose this part. So recommend restaurant name Au Midi, neighborhood Midtown, who is in French. So Au Midi is in Midtown and serves French food. And there is a French restaurant in Midtown called Au Midi. So these two are equivalent responses, and these two are valid answers. But suppose now we are talking about a new restaurant, Lodge Fine, and neighborhood is city center, and cuisine is seafood. So it will be like this. Now this problem may come like what he was mentioning. So how do we generate this one, ensure that we are not generating this? And at the same time, if you look at your training data, this restaurant name may appear very less number of time. This restaurant name may appear in very less number of time. Then what happens to the probability of generation of those tokens? So is there a chance that this will get lesser uh, value because this value was not seen a lot number of times. So the probability associated with this may also come down. Or what if a new restaurant is there? So due to which this template based or delexicalization happens. So firstly, what will happen is that the system will produce something like this: name has decent service. And then you look into your dialog state and see what is the name that we are talking about. Now you replace the name. Now, although the name may vary, but this kind of pattern could be quite prominent in the data. So this kind of generation is much simpler. So this is called sentence realization, where we map the frames to delexicalized sentences. So this is called delexicalization, where the actual name we replace by the tag. This part will skip. So here, I think there is one more recent work afterwards. So again, I'll not go too much deep into this discussion. So what people observed in various dialogue systems is that there are many repetitions. So So this one, where are you going? I'm going to the restroom. See you later. See you later. See you later. See you later. Like that, it repeats. Huh? Then, how old are you? I'm 16. 16? I don't know what you are talking about. You don't know what you are saying. I don't know. So these kind of nonsensical responses, these kind of repetitions were very, very prominent in the generations. So how do we take care of that? So now they in this paper, it has also become quite old now. It came in 2016. They proposed reinforcement learning for uh, dialogue generation. So where are you going? I'm going to the police station. I'll come with you. No, no, you are not going anywhere. Why? So as you see that I mean, this is only one example. It doesn't say that all the responses are good, but the philosophy that they have is that can we have the dialogue generation in such a way that these kind of repetitions are avoided and meaningful responses come into picture. So essentially, if you look at the loss functions, this language modeling loss, right? At each and every instant, what was the ground truth generation and what you are generating. Based on that, a cross entropy loss is computed. So that means at every token, you are computing that loss and you are summing this up. So that means a very local decision, a very greedy kind of decision that is being taken. Instead of that, what if you ask the system to generate everything and at the end you see what it has generated, accordingly you compute the loss and then you do your parameter updates. So reinforcement learning helps in this kind of scenario where you allow the system to take local decisions, but finally you judge whether it is able to achieve what you are trying to do or not. So typical examples of reinforcement learning could be like, well, cycling, right? How much pressure you are putting on the pedal, what is the cycle handle, which direction it is in. Everything you cannot dictate, right? So, but ideally, if step by step we want to do that, we have to put those values and ask the system to match those values. But finally, it says you take all these actions, but finally, you have to reach this part. So essentially, the system will automatically try to learn how to handle, how to hold the handle, how much pressure to put where, and all those things. So here they try to look at there are different things. The state is the concatenation of the previous two dialog turns. That is the state, which is input to the encoder. Then action is the dialog utterance to generate. So here when it says action, it's the final response. That's the action, and there are infinite number of responses, right? And then the policy says that PIQI, that is the past two responses, what is the response that you are generating? So essentially, we want to have a policy network that identifies the best dialogue best turn. And the reward is key. We want easy to answer, non-repetitive and semantically coherent response. So this reward function, they have many components. So one is that ease of answering. There are some responses which can be given very easily. I don't know. I don't care. Then so essentially, we want to give lesser score to those kind of scores. So here it tries to mention those. So if the likelihood of the response is very high, you see it in a lot of conversations. It's very easy to generate. De-emphasize that. So that's what it is trying to see. Based on the action, if this state has a very high probability, you get a negative reward. Then this is something that I was also mentioning earlier. So there are two consecutive generations by the chatbot. One is HPI, and the next one is HPI plus 1. We're seeing how aligned they are. If they're very much aligned, that's a negative reward. Okay, avoid repetitions. Then high semantic coherence. So high mutual information between two consecutive answers. So you are not deviating too much from the topic. So yeah, QI, PI, based on that your action, and based on the action what you are generating. So between two consecutive answers, this is a positive reward. They have formulated the reward using probabilities of these two, and it has to be high. And finally, all these, when you combine, it is achievable. This you can obtain only after that entire sequence has been generated. Now you know how good your response is. So it's not a loss that you are computing after generating each and every token, and using that you are generating the next token. No. So this is one approach. And then Yeah, this entire reward is the combination of all these. So skipping this one. And then I think before, all right, I hope we are back after that much needed break. So we'll try to close that dialogue part soon. Okay. Yes. So we talked about different components. We talked about identifying the intents, identifying the domains, the dialogue act, the belief state, and stage-wise we do all those. But then there are smart people who say, why can't we do all these things together? So this is one such work where we have they want to do multitasking. So typically we have the dialogue history. From that, we want to predict intent and slot. Then the belief state. Belief state is the dialogue state. And then the database state, like whether your database search was successful or not. Then dialogue act, then response. So we can, yeah, so this is the typical pipeline: understanding, dialogue state tracking, dialogue policy learning, and generation. So this is something that we have told multiple times. And suppose this is the dialogue history. This is the belief state. This is the database state, which is restaurant 1 is a match. And this is the response, where we have firstly the delexicalized response. The restaurant name is a great value food restaurant. And we fill in the values to get this system response. So this work is by Microsoft. So what they do is that they have the dialogue history, belief state, database state, response, everything together. And it comes as a autoregressive kind of prediction. So the entire data would be like this. Firstly, user, system, user, that's the dialogue history. So which comes here. Then the belief state, they encode like this: belief state, colon, restaurant, price range, and all that. Then EOB is end of belief. Then there is something which even I cannot read from here. And then there's the response delexicalized. At the end, there is the EOS token. So this entire thing you give, and this is how you do the prediction. The X is what? This entire thing. Okay? And you are trying to find the probability of X. So here, this prefix part is always there because the dialogue history is known to you, but the other things are not known. So it tries to predict all these things. And essentially, they're trying to do these multiple tasks together. Right? TSEL 2021 by Microsoft. Okay, so we have seen all these. What is dialogue? What are our expectations from dialogue systems? Introduction to automated dialogue systems, types and examples, generation strategies, retrieval generation, retrieval augmented generation, and components in a dialogue system. Now, how do we evaluate? There are many techniques. So if we are talking about goal oriented, we need to identify, we need to make sure that the dialogue state is correctly identified. If we mess up there, some value we are unable to pick, or we pick in a wrong manner, the final thing will go wrong. So essentially, how do we identify our dialogue state tracking is good. There are many techniques. Joint goal accuracy says that the entire dialogue state that you have predicted, include the domain, the exact values of the slot, all these things should exactly match with what we want. So like that, so only then it is a success. So that is good, and this is something we all should want to achieve. But the problem is that when these systems are still very nascent, people are trying to develop good systems. But what is happening is that some field where the value is mispredicted slightly. What do I mean by slightly mispredicted? Maybe there is some spelling that has got incorrect, or south side, these kinds of things due to normalization that has got missed out. Or yeah, so in those cases, versus there is some dialogue where everything is grossly miscalculated. So both actually get a 0 value. Now for the development purpose of these kind of systems, ideally we should give higher weightage to the work which is able to get some of the dialogue states in the right, with the correct values of slots and values identified. So to promote the dialogue system research, we felt that joint goal accuracy should have a relaxed version. Otherwise, all the systems will have zero value of the utility or high value of the loss. So that was one thing. And the other, there was one more point, which is that these are incremental in nature. As we said, Dialog said, some values are mentioned, then some other values are mentioned. It's an incremental or cumulative. And suppose the system has made some mistake at the beginning, and which is staying with it due to the cumulative nature to the 10th occurrence also. Still, we are saying this Dialog is bad, although it has done correct prediction for the rest 9. So somehow there should be a metric which gives importance to a cumulative behavior, but at the same time, it allows the system to correct itself, which is there all human conversations also. And when we talk, maybe there are certain things we are not able to pick correctly, but we rectify that. But even with that incorrect option, we try to go ahead with the conversation. Finally, we reach the conclusion in the right manner. Somehow, in order to motivate the dialogue system research to go in that direction, we thought that there could be some flexibility in that metric, which is joint goal accuracy. So we came up with something like flexible goal accuracy, where some discounted weightage is given to the losses, and losses are also we categorize into 2 different types. One is whether it is propagating from earlier or it's a new mistake that we are making. So based on that, the weightage changes, and we have flexible goal accuracy. So we penalize for errors made in this turn, but discount the penalty for errors made in earlier turns. So the systems which were initially wrong, but they are doing correct currently, we try to favor those kind of responses. So that is one. And there are many metrics. We said that at surface level, we can have blue, meteor, other kind of scores. Then matching at the content semantics level, we can have bird score, word mover distance, which look at 2 different sequences and try to see whether they are semantically matching or not. Then how fluent they are, for that perplexity metric is there. These are all well-defined metrics in NLP. And then we can also have something like emotional quotient, the empathy, the politeness, these kinds of things could also be there. And the bottom line is that none of the above metrics capture the true usefulness of the responses. So each metric has its own downside also. So, but then in modeling also, the way we do ensembling, hoping that, okay, some models inconsistency will be overcome by some other models, or the variance comes down. So see, with similar kind of philosophy, we feel that if we have a method which does good according to all these metrics and a majority of these metrics, maybe that system is good. So like that we have, but the point is that human evaluation is the best possible evaluation for dialogues. Then we thought of proposing one more metric, which tries to capture the groundedness and some other aspects. So what it does is, so what we see is a good quality response often contains cues related to the ongoing dialogue context. So if you look at one response, from that, if you have to tell what are people talking about, what is the focus of this discussion, you should be able to get some keywords for that. So however, if not, then the response is either incoherent or it is random. Say, for example, I give you the text that I don't know. Can you tell me what was talked about earlier? Will not be able to guess. However, if the response is that, okay, IIT Gandhinagar is located in Gujarat, if that is the sentence, possibly you will be able to get some idea regarding what has been talked about earlier. So what we do here is that we do this. We look at the response. We mask some words from the response. And from the context, we should be able to predict these words. So here I'm talking about a reverse direction. So there is a context based on which we give a response. From the response, we mask some words. Which words? There are some keyword extraction methods. We identify those keywords, we mask them. And based on the context, can you fill these masks? If the model has better prediction accuracy for these words, then the response is good. Otherwise, it's not good. So take a response, mask some important words and predict these masked keywords. And it uses high quality. I mean, we can use high quality denoising model. I mean, we do not need to train something. We can train, but otherwise high quality denoising models like BERT and other things we can anyways use. So that was there. So dialogue context is there. and keyword masked utterance UT is there. And there could be some conditions. So if it is like knowledge rounded retrieval, then some additional knowledge, retrieve knowledge can be here. If it is persona aware chat, so this persona can also be there. So essentially, these masks can you predict with the remaining information which is available. So this is the, no relearning for separate data sets. This again has been one focus, that with so many of pre-trained models available, we do not want to retrain for any specific data set. Otherwise, there are many methods which try to have scores and then combine those scores, and each of these combination weights are learned based on the data set. We do not want to take that. So what it says is that based on the dialogue context and the mask response and the additional condition like the knowledge extracted or the persona, you try to predict each word from the tth response. So yeah, this small t indicates the tth timestamp, j is the jth word. So for each word, you try to predict its probability and then you average over it. And then, this is the overall score, and we prefer the lower scores because there is a negative sign here. So we saw some examples here like, so this is a persona conditioned context generation. So context is there, condition is there. The response is my 3 kids love mint chocolate chip. Overall score was 555, average 5. And so there are scores given by 3 annotators. So all of them considered to be good, and it had a low score. We said lower scores are better, so it's good. On the other hand, here we are talking about ice cream, cookies, and so on. And he said, I like the color red, things, and I like the color blue. So of course, it's a bad thing, and it got a very high score and like that. On the other hand, if we really want to achieve what we said earlier, that the very prominent responses, the responses which are very generic, those we want to avoid, this thing does not work. The other, because here we are trying to predict the keyword, mask keywords from the response. Now, if it is a very generic keyword, there is anyways a high probability of predicting that, right? So for those kinds of cases, it will not work. Some reverse approach needs to be tried. But if we are trying to see whether our response is grounded on the available context, this one actually is able to do well. And we have said this, we have checked it as a generic metric for different other kinds of applications as well. I think that's what I'll skip this part, knowledge grounded. Yeah. So are there any questions related to the dialogue systems? After that, we'll give an overview of the question answering part. Yes. Yes. So three annotators scored it as 5. Yes. So they have given mostly relevant to the context, and then there is fluency and other things, but these are mostly fluent. So correct. No, we did not explicitly report it. We saw it's very much in order, but we didn't compute and didn't report. Okay. Yes. So joint goal accuracy, as we said, it's a 0-1 kind of metric. So you ask a kid to perform a multiplication, 4 digit by 4 digit, make some error somewhere, final result is wrong, you say there is a kuch nahi hoga. On the other hand, you say that, okay, in the last line, in the summation part, the kid has made a mistake. You say that it's mostly correct, but you recheck. FGA tries to mimic that second behavior. It may be incorrect when you match, But this incorrect nature may be from due to different things. Maybe at the very beginning he made a mistake and that percolated, because we are talking about cumulative goal and dialog states, right? So somewhere it makes some mistake, but later on it goes ahead. Both. So it can be that way, or initially it was doing good, but finally it goofed up somewhere. So that also. So what we do is, at each and every state, due to cumulative nature, if we see that it is not matching, it can be due to two reasons. Firstly, the error has been made in this utterance itself. Secondly, it was done in some earlier utterance. So if it is made in this utterance, for this utterance, the score is 0. And anyways, we are having a cumulative score. And if it is not in this utterance, so the score is a factor of when this error was made. If that distance was x, then it is something based on e to the power minus lambda x. So some discounted, so past errors we forget. So if it is some 10 or 20 utterances earlier, we forget about it. Yeah. Okay, so we will go to the question answering part now. So let us look at some different types of questions. Let us ask these questions rather. Who won IPL 2014? People do not watch. Oh, okay, yeah. All right, take care. Then if 40 out of the 50 participants are sleeping, how many are awake? Okay, some people are awake. Songs Offerings is the translation of which famous book? No one? Yes. Huh? So the book that fetched Rabindranath Tagore become the first Asian Nobel laureate in 1913. Why did most of the ancient civilizations came up near the rivers? Long answer, right? Why should I turn off my mobile in flight? Yeah, so there are many other reasons. So if you ask ChatGPT or a Gemini, no, I tried this and they said that, okay, if you turn it on, you'll be focused on that and you'll miss the announcements made by the crew and various other things they said. Uh, then who is the best cricket captain India ever had? Okay. Is the move to replace the IPC by BNS justified? What is IPC? BNS? What is that? Bharat Nyaya Sanhita or something like that. Hmm? Okay. So what we see that there are some questions which are short, one word kind of expression, right? There are some questions which are narrative in nature, like why did most of the civilizations came up near the river? So there are many reasons, because water is very much required. Then water makes also the land becomes fertile. Then, people were mostly, there was no McDonald's or KFC and other things. So you grow your crop, you catch fish and other things, transportation becomes easier and all that. Right? So there are multiple factors and this is a descriptive answer, right? It's a narrative kind of answer. Then sometimes it could be like list also. Instead of the best cricket captain, you can also have the 3 best cricket captains according to your. So the answer can be a list. Then you can have opinionated response, like is the move to replace IPC by BNS justified? Or it could be factual, like this is factual. This is at the same time short or one word. So there can be combinations also. And this also is factual to some extent. Yeah. Then there could be reasoning based. Do you see any reasoning based question here? Second one, so mathematical reasoning, right? Yeah. Then there could be questions which are open domain questions, which are a generic question and you have to fetch your answers from anywhere. There could be some passage based questions like reading comprehension. There is a text and there's a question, you have to give your answer to the question from the text. Then there could be knowledge base. Instead of an unstructured passage which is given to you, there is a knowledge base. You query that knowledge base. So like you have a query, you convert it to, possibly you convert it to some structured language, and then you query, you get the response. Then there could be extractive answers, like a substring from your passage is the answer, or it can be a massaging of the input which is there to get some nicely curated answer. So that is the abstractive part. So when we talk about question answering, there's so many different things which are possible. And if we want to have a solution for this, we need to keep this in mind. So mostly there are many systems which try to address a subset of these questions. And there are systems which firstly try to identify what type of question it is. And accordingly, they have their solution strategies. And there are many questions, many data sets for each of these things. For reasoning, there are data sets. For factual answers, there are data sets. For open domain question answering, there are data sets. Reading passage-based data set, knowledge-based question answering, there are data sets. So you identify what kind of task you want to do. You pick your data set, try your model on that. And nowadays, what people are trying to have is treat entire thing as a black box. And that's where this prompting to get answers that is coming in, right? So, but then how do we fine tune? There are so many different data sets. See, I want to have a question answering system that will be applicable for all these kinds of data sets. So how do we separately fine tune for all of them? So that's where the instruction fine tuning comes into picture. So you take examples from the data sets. From these examples, you try to come up with some reformatting of the questions so that it can be treated as an autoregressive generation. For example, suppose there is this question is there. Which team won IPL 2024? And suppose there is a factual a database for these factual questions, question answers. So you can have the question and the corresponding output. Then for the narrative also, you can have question and that answer. List also, you can have question and comma separated list of output. Then when it comes to passage based, you have to give the instruction in an appropriate manner. You can say that consider the following passage and come up with the answer to the following question. And then whatever is the answer, you give it. The same thing can be for abstractive, extractive. So essentially, whatever data set you have, you pick instructions from there, and finally you do some transformation so that now you have a massive data set which is formatted in a very consistent structure, where the input is a sequence, output is a sequence. And now the input sequence, what we say, so there it will be definitely will contain the instance. At the same time, it can also describe what is expected out of it. Say, we can also have the inferencing kind of question, like, are you aware of the NLI, natural language inferencing task? Can you explain what is natural language inferencing or textual entailment task? So here, let us assume there are two sentences or two text segments as input. It can be single sentence, multiple segment. So the first sentence says that who was the first Indian to go into the space? Huh? That's okay. First one was a hallucination. The second one is correct. Rakesh Sharma. Huh? So yeah, Indian, right? So Rakesh Sharma is the right answer. Which year do you remember? 19. No. Late 19 years. No, it's 1984. So suppose the first sentence says that the Rakesh Sharma is the first Indian astronaut to go to the space And the second one says that no, Rakesh Sharma is the first Indian astronaut to go into the space. He went in 1984. The second sentence says the first Indian astronaut went to the space in 1984. Do you think these sentences are related, or the second or one sentence entails the other? One sentence follows the other. One sentence can be obtained from the other one. Rakesh Sharma was the first Indian astronaut to go into the space. He went in 1984. The second one says the first Indian astronaut went into the space in the 1984. Yes, there is an entailment here. On the other hand, if we say that the first sentence remains the same, the second sentence is IPC is replaced by BNS. Any connection? No, unrelated. The third case, the first sentence remains the same. The second one says that an Indian astronaut went to the space in 1980. Do you think it entails? It actually contradicts, right? So natural language inferencing task can have three possible levels. There are some datasets where they talk about two levels only. One is entail, second one is contradict, and you can also have a third level, which is unrelated. So even that is some kind of question answering. You can pose it as that given these two sentences, can we infer that there is an entailment level, or which one of the following levels are possible? So task was different, but we can actually pose it as a question answering task. So what is happening when we construct the input? We are having the instances. At the same time, we are giving some task description that based on these two sentences, you have to pick one of these answers, one of these, possible answers. So that is why this becomes instruction fine-tuning. So the task we're converting into an instruction, and also we're in some sense translating or reformatting the input. This entire thing goes to the system as a sequence. You have to predict the output sequence, which will be the expected answer. So nowadays there are systems which try to look at many different data sets, not from only the question answering task, for various other tasks, and using instruction fine-tuning, they try to get to the answer. So now everything is question answering. All right. So today we'll not talk about LLMs, but we'll talk about some other techniques which exist for this kind of question answering. But these concepts are used in many LLM components now. Okay. So answering open domain questions from external reference. So this is somewhat similar to RAG, if you are able to establish that connection from the title. So so this is the original pipeline for that one. You have a question, you'll process that question to identify what kind of response is expected. Now, based on that, you do a search by identifying a query, and whatever search results come. So here the thing is, you will not get one answer. You will get many different passages containing the answers, or many different answers, and from that you do an answer scoring to pick the best answer. So there are so many things that you have to do on your own, which now happens behind the scene. So question pre-processing to get the question type, then the search part. Where do we search from? Is it search from local store? Is it search from a global store like a web? And then how do the answers come to us? Do they come as passages from which the answers have to be extracted, or do they come as short answers? In some cases, short answers will be there. In some cases, short answers are not possible if they are descriptive questions. And then how do we score and pick one, or how do we combine together, and from there we get the final answer? So these are the things. Now, this is one such approach. From the question, you formulate a query. Now, this query formulation can be, it's a very broad term. It can be at the level of keywords that you extract from the question. It can be the keywords plus some query expansion to have some related keywords. It can also be creating a prompt. Okay. And then you also detect the answer type, what kind of answer you want, because even if you want to do instruction fine-tuning, you need to be very specific regarding what kind of answer you are trying to fetch. from the system. Then once that is there is a document collection which is available with you. Some indexing will be done on top of that so that the retrieval becomes much faster. And from that, you retrieve the documents based on which the answer can be generated. Now, once you have these relevant documents, some documents may actually contain pages or paragraphs of information. So we do not expect that the answer, the entire document and collection of so many documents, everything will be the answer, right? So can we identify the relevant passages from these documents which are most likely to contain the answer? Now, once you have these passages, so these passages and this additional information like answer type and query, based on this, you get the answer. Now, the central piece of query formulation and passage retrieval can be replaced by LLMs today. However, so is also the fact this entire process is shifting to LLMs where this entire part is now becoming a black box. But internally, many of these things happen in principle. However, there are some issues which are related to the recency, conflicting responses, etc. So if you try to refer the web to get the answer, most likely you will be getting the recent answers, and otherwise the LLMs need to be updated every day with every single piece of information. Even if you want to do RAG in your vector store, you need to have all those things present. So it depends on what kind of things you want to, what's the nature of the data that you are trying to handle. And accordingly, you can see whether this is really a limitation for you or not. So these are question types. I'll skip this part. And this is actually IBM Watson system. So this became very famous in, I think, 2011 or 2016. I'm forgetting the year. So there was an American TV show. You may have heard about it. It's a Jeopardy was the name of the contest. And there were a couple of users or a couple of players who won that consistently. But then they had these two players and the IBM Watson system. And this system was generating the answers on the fly by following this architecture. And it defeated the two humans. So that one was really people say that one major checkpoint in the advancement of AI. So the kind of approach that it did is this, which looks very cumbersome and is very cumbersome. So once it looks at the question, it tries to get many such information like focus detection. What is the thing that it is focusing on? So lexical answer type detection, question classification, parsing, name-related tagging, relation extraction, co-reference resolution, all these things. Essentially, I mean, any basic NLP functionality that you think of, almost all of those are present in this. They're doing all these things in parallel to get a better understanding of the input, what kind of answer is required. And they try to get some information from structured data using database kind retrieval. So here we have DBpedia and Freebase, which are knowledge graphs. And this is from like the open web, where we have unstructured documents. So from here also they have answer extraction. So document title, anchor text, from here they get. And now they have a large pool of content from which the answer can be curated. Then they have this candidate answer scoring. There is a scoring function that needs to be applied on this to get the thing. So there are many components there: text evidence code, the time information, the recency information, then answer type. Then they also have something from Facebook. And once these candidate answer scores are there, then you have so for each answer, they have a confidence score. They do this confidence score merging, and they do some kind of, so there could be some answers which are equivalent. So Charles Dickens, Mr. Charles Dickens, all these are same. And for each of these things, we are getting separate scores. So somehow we need to identify what are the similar entities and combine them. So all these things happens in this part, and finally the answer is there. So this one was able to beat the humans. Nowadays, the situation has shifted. A lot of operations are being done using vectors or contextual vectors. So here, what happens is that suppose we have this question: what does the zip in zip code stand for? So they have this question, As in BERT, they have the CLS token at the beginning, a separated token at the end. There is no second segment here, and they get the BERT representation of the question. Now, for different documents like 0, 1, 2, 3, so suppose these are the different candidate documents which are there. So here, what they have is CLS, then the first question, then the, so they have some similarity score with the question, and the top K they take from here. And now from that top K, they check that question answer alignment. How do they do that? CLS, then they have the question separated, then they have the text. And they get the representation for this complete sequence. So here also the same thing, CLS, the question is there, and then this passage, which is another top K passage, and then separator, and then they get the BERT representation for this combination. Hope is that if question and answer are aligned, the score, that should be captured by the BERT embedding. Then this one, they try to, based on that, they try to do some other processing to get the final response. So there are some MLPs where, so essentially they try to look at the start offset and end offset of the question, of the answer. And from that, they can extract the answer. For this answer, they get the score. They try to obtain the scores using MLP. They combine them. So like that, they did it. Now, that is being done in many of the systems now using dense passage retrieval. And what if our question is coming from we have to answer from the knowledge base. So here, so this is a fairly recent paper from 2024. So suppose the question is, what is the name of the opera based on 12th Night? So what they try to do is, so only specific kind of questions can be answered, and they have to be present in that knowledge base, right? And in knowledge base, we know that there are some entities and relations, or yes, right, entity relations. And also there is something, entity type is also there, correct? So the name of is a crucial cue. Opera based on 12th Night. So opera and 12th Night, these are the entities, and name could be the attribute, based on could be a relation, correct? So by looking at this, they try to extract these entities and do this entity linking. So from this database, what are the entities they try to identify? And then they have the relationship linking. So instance of is actually the attribute type can also be there, and based on is a relation between two entities. So they also have this. From that, they create a query. So the natural language description, they convert to a query. That's the bottom line. Now, how do they do it? It depends. So you can simply have a translation model, a sequence-to-sequence translation model, or sequence-to-sequence model, or many other things, where you can also make use of this basic pre-processing first, which will possibly give you better translation quality or better query quality. And then once you get the query, you execute it, you get the answer. So this is typical, one common way of answering questions from knowledge bases. And how about input passages? So this is a reading comprehension passage. Input passage means reading comprehensions. So passage segment says the European Parliament and the Council of the European Union have powers of amendment and veto during the legislative process. The question is, which governing bodies have veto power? Answer will be this yellow part. Similarly, there could be another larger passage where different sentences are there. And the question is, what other role do many pharmacists play? So this sentence contains the answer. Pharmacists may also be small business proprietors owning the pharmacy in which they practice. So the answer is small business properties. So these are from the SQUAD dataset, Stanford question answering dataset. So the answer may be a substring from the passage. If it is a substring, only the encoder based techniques could be useful, because we are not generating anything as such. We are not generating any text as such. Substring means as long as we are able to predict the begin offset and the end offset, the answer is eventually extracted. However, if the answer is not a substring, or there can be situations in our setup where the answer need not be a substring, then we will need decoder-based approaches. So this was one paper from 2017, which is called BIDAP, which became quite popular. So So here what they do is they have the context, which is the passage, and they have the query. Okay. Now they get representation of the context. When we say representation of the context, for each and every token of the context, they have the vectors. Then for each and every token of the query, they have the vectors. Now, if there are t words here, t words in the context and j words in the query, they created t by j matrix, which is the context cross query matrix. Similarly, they have the transpose of it also. And suppose we are talking about context to query matrix, that is t cross j matrix. So here each entry will denote what is the possibility, what is the probability that this word in the context aligns with this word in the query. Similarly, they have the reverse also, context to query and query to context. So from both the directions, they are trying to see how well this query token and this passage token match to some extent, so that they can be the final answer. And based on that, they compute the attentions and combine this, and finally dense layer plus softmax will give us the start and end tokens. So these are the different things. The embedding also they obtain in many different ways. Word embedding plus character level embedding, they combine. Then from that they get phrase embedding, then attention layer. Above that, the by LSTM. So they used by LSTM. It was from 2017. Transformer came later. Then we know that I think something of this sort might have been explained to you already as part of this summer school. Not sure. So you have the question, you have the paragraph, CLS, question, separated, paragraph. So this entire thing is there. Then you can have segment embeddings. You combine, you have position embedding, you combine them to finally get the initial representations that goes into the BERT. And layer by layer, the representation will be modified based on the self-attention. And finally, for each token, we'll have the final representation, which is coming out. And based on that, we predict the start and end span. So what does it do? So for each token, so for the ith token, the hidden representation that is coming out is hi. We multiply with w, and this gives us a multiply with a w, which is a parameter, and then we apply softmax on it to say what is the probability that this word is going to be a start token. Similarly, we check what is the probability this word is the end token, and then we take a greedy decision that okay, this is the start offset, this is the end offset, and then we can just extract the answer corresponding to that. So right, so if the question is like how many parameters does BERT large have, the question is here, there is the reference text, it comes here, and how many parameters, it will be somewhere here, 1024. We expect that start and end will denote that. So thing is, a fine tuning will be needed with this kind of data set, where we can freeze the BERT layers. I think that's the best, that could be the best thing to do, and only have the parameters that dictate this, what is the start word and what is the end layer. Okay. Then there came a very interesting approach called span BERT, which is somewhat similar to BERT. So in BERT, you know that masking is done. So how do we prepare the data for BERT? Essentially, it has two objectives. Does anyone remember what are the two objectives for BERT? Huh? Masked language modeling and next sentence prediction. Next sentence prediction is kind of simple. Masked language modeling, how do we mask? Suppose a document has n tokens, an input has n tokens. We generate some random numbers in the range 1 to n, roughly 15%. And whatever random numbers get generated, those correspond to the inputs that we may want to perturb. And for each of those things, we make one of the three decisions, whether we want to retain it as it is, no masking, so double bluffing, or we want to just replace this word with mask, or we want to change this word by some arbitrary word from the vocabulary. So these are the kind of noising that we do. And finally, the method has to tell what is the correct answer, or what was the correct or unperturbed input. That's the denoising task. Here they said, we'll do masking, but we'll do in a different way. We'll not mask random words from here and there. We'll mask spans. Okay. So essentially, what they identify how many spans they want to mark. And the length of spans, there's a geometric distribution that they pick. So there are two things here. Where should I start? What should be the starting position of the mask? And how many words in sequence I have to mask, right? So there is one random number that identifies the mask, the position, initial part of the mask. And then there is another random number that says what is the length of the masking. The first one can be uniform. Any word can be the starting point. And the second masking, the second parameter, which is the length of the mask, they have the geometric distribution. So essentially, shorter masks are preferred. Larger masks, the probability is low. Essentially, their masking range is between 1 to 10 words. Average became 3.8 because of this geometric distribution. And then they have this mask word prediction. But if you remember in BERT, the mask word prediction, the loss function was cross entropy loss. But here they have one more loss. Cross entropy is there because every word needs to be predicted. I mean, every masked word needs to be predicted. And the second one, they say that if this is the sequence that I'm going to mask, let me predict this masked word based on this boundary, and this position. So these 4 words are masked. The word before the first masked word has some cue about the left context or about the context. The word immediately after this last masked word has some other context. So I would feed these 2 contexts as well as the position of these masked words like I. Otherwise, and these 3 things will give us an embedding, a new embedding for this masked word. Okay, it's not new embedding. So I want to predict whether what is the masked, what is this masked word based on these 3 inputs, let us say. Okay, so given the left boundary, right boundary, and the offset, can you predict the masked words? Now, otherwise, if you do not have this I, the position, essentially for each of the words, the input becomes the same, right? If we only have the left boundary and right boundary, for this word, this word, this word, this word, for all the 4 words, left boundary and right boundary are the same, was and to. So we need to identify something so that these things are different. So that is the I, what is the position of this word. Now, based on these 3 inputs, we want to predict what is the masked word. Now, that is called SBO, I think span-based objective, an American football game. So if you look at the third word, football, so it's the masked language prediction log, MLM loss for football, plus LSBO of football. So how do you get the masked language prediction loss? So the probability of so this token X7, based on this, what is the probability that the word is football, minus what is the probability of this word being football given X4, which is this one, X9, which is the end, and P3, which is the position of the third word in this mask, in this span. And they saw that wherever you want to predict some span, this span BERT is actually doing wonderful. So they compared with Google BERT, which is the first blue thing here, then their implementation of BERT, which is the green bar, and the span BERT, and they saw that across all the different data sets, they're getting much higher performance. Yes, and in most of the cases, the answers were extractive in nature. So now this is the only training part, but when we are predicting, okay, this is only the training part, this masking. As we know in BERT also, we do this masking for the pre-training part to make the model understand the language. But when you apply for a certain task, we do fine-tuning on that data, right? So, and for inferencing, what do we do? Passage, separator, and question. We give it, and output of the model is the start and the end token. So our goal is to predict this word. Yeah, these 4 words. So we'll compute the loss for each 4 words and we'll sum or we'll average. Okay. Let us focus on this word, where the correct value is football. We want to predict it. So essentially, if you look at the ground truth, it's a one-hot vector, where for football we have 1, everything else is 0. And if you look at the predicted probabilities, we'll have some probability distribution. Based on that, we compute the cross entropy that is happening as part of the MLM part. Now, for the second part, we want to see whether based on only the span information are we able to predict. So from the context of the entire sentence, are we able to predict? That's the first one. Second one, from the context of the span, are we able to predict? That's the second thing. The second objective tries to capture that. How? So if it is a transformer encoder, after it comes out of the final layer, each word has an embedding, right? Each token has an embedding. Now, for this word, we want to predict it by looking at 3 inputs. The begin boundary of the mask, which is the word which is immediately to the left of the first mask word. The end boundary of the mask, which is immediately to the end of the word. And the third input is the position of it. You can use the positional embedding or something. So now you can assume that you have a neural network which has these 3 inputs, and then it is producing one embedding that you project to the vocabulary space, again a probability vector. And with this probability vector, you compute the cross entropy now with the ground truth. So that becomes the second objective function. So if you are doing good here, that means it has a good understanding of what is the span. So to sum up, so these are the different QA techniques which exist. The first one is retriever reader, which were the Jeopardy kind of, Watson kind of system. You have a question and you have an external knowledge base. You have some kind of retriever. It can be BM25, dense passage retrieval, divergence from randomness. There are quite a few information retrieval techniques which will give you ranked contexts. This context is a overloaded term now. It can be individual sentence, individual passage, or a document. At different levels it could be. Now there is a reader which looks at all these things, and it does some filtering of the contexts, from which you predict the start and end token, you give the answer. So that is one line of work. The second one, you have the question. Again, this passage ranking is there. Now, these questions will be there. I mean, this context will be there. And now a generate will generate the answer from there. It's not start and end token. It's not extractive. It can be abstractive. You can have any sequence that you generate based on the question and the selected references. And the third one will be you combine entire thing inside a block, and that itself will give you the response. So this is the retriever reader, this is the retriever generator, this is the generator. Based on whatever information is available in the parameters, whatever knowledge it has learned, whatever understanding it has been able to encode or store inside the parameters, that thing will be for the answer. So these are the 3 main categories of question answering. When we talked about dialogue systems, essentially there also we had three part: retrieval, generation, retrieval, augmented generation. So here also we have 3. Generation is there, retriever, augmented generation is also there, and this one is slightly different, where we predict the span and do not have any abstractive answer. Okay, summing up, I think almost time. So QA is an important task for multiple reasons. You can use it for many different things. You can get direct answers. You can use it for information extraction. You can identify semantic roles based on this, and you can essentially, the instruction fine-tuning has shown that using QA, you can do almost everything. Now, many instructions for training model LLMs are questions only, and many types of questions, and QA system needs to be robust to all categories. So a proper QA system has to be robust to all the categories. Answers can be substrings from passage, where encoder-based models would work fine. However, if the it should be abstractive. Abstractive answers require decoder-based models. So you can also have the, everything combined as an input. You expect your decoder to generate the answer. Major shift in approaches, different combinations and training strategies for retrievers. Those are there. So how do we retrieve the text? There are many, many different techniques that people are experimenting with, because a simple and crude technique will not be able to scale. So there are different training strategies which people are trying for retrievers, readers, the answer generators. There are many models, but none of them is perfect. So hopefully with time, we'll get better and better systems. And yes, it can be multimodal as well. So I think you have heard of visual question answering and things like that. So yes, we're not only restricted to the textual part, but some vision and language can also come together here. Okay, so if there are any questions, you can ask. Otherwise, we are done with the first session for today. Yes.
These are all like how the sentences form and how the structure, what words they are using.
So this was for evaluating the dialog state tracking. And dialog state is a very structured kind of input, slot and value. So these are for checking that, not the final response. If the final sentence that is generated, if that you want to evaluate, then there are some NLP-based metrics like blue could be there, meteor could be there, perplexity is there. Then you can have embedding similarity. So all these options are there. But if you are checking whether the dialog state has been captured correctly so that my next action is, like, I can be much more confident about next action. So there this JG and other things come into picture.
That these evaluation metrics, I see very less people using these. Using either blue, role. So I want to ask a distinction between them. When you use this, what are they are benchmark data sets and these are metrics. We try evaluation. The difference can be highlighted.
So there, depending on the task, what we want to measure, what we want to use, what we want to measure, that metric value may differ. So there could be values, say for example, if there's a counselor who is talking with a patient, so some other kind of things like, is the person able to recognize the emotion? So the emotion identification becomes an important metric there. So is the person being sufficiently empathetic? That becomes, there are some situations where the systems try to engage the users in longer conversation. So that how long the conversation is. So depending on the end task, we'll try to get different metrics. There are many other metrics, like there is something called a USR. I think usability, specificity, and these things. So which try to assess how useful the response is. So there are different things which can be combined here. And I think the datasets that you have mentioned, depending on the task formulation there, they might have picked the metrics.
The sentence of hotel or so it was very correlative data set like data set like so it also does the same thing. Like there are two subjects of two objects and it just changes focus. The sentence meaning is like focus on this object or that object. So that I felt like that data set also have been, it's very big.
Yeah, so here it was like the focus was more on generating the state and from there generating the dialogue and how we are doing in these individual things. However, there are data sets, as you mentioned, where given two things, you identify which one is being talked about, right? So there is also one task like this which is called Winograd schema challenge, right? So there also to test the understanding capability of the natural language system. So these kinds of things will be there. So the focus is that given two are we able to sufficiently understand this kind of very minute kind of differences? Yeah, that can be used. Yes, yes. But here, remember, you have these two inputs. You have these two inputs which differ in very minimal way. If the input is of that nature, yes, you can use that metric. Yes. For generating answers. So there are many prompting techniques that people are using. I don't recall, but there might be a survey of checking which kind of prompt generation techniques hold for specific kind of question answering. But there is no paper or reference that comes to my mind immediately. So essentially, by looking at the question, can we come up with the prompt on the fly so that the answer would be yes.
That require like mediated answer. That would be multiple possible. So it would be reasonable to compare it to the single.
Right.
That case would be evaluated without the.
So there are some metrics for reference-free evaluation also. There are some metrics for reference-free evaluation. And when it comes to this kind of opinionated answer where there is no single ground truth, this kind of metrics could be useful. I think USR is one such metric. There are quite a few others also. And yes, so there are metrics which does not require you to look at any specific ground truth. That's a good question. It depends on multiple factors like the system architecture, I mean, the system resources and so on. But if it is something where we expect even all the tweets which is coming typically in every microsecond, and so there most likely at the very beginning they can sit in some vector store, but the model retraining can happen, but at least the data should be there. Or if it is something live cricket score or yeah, so we need very frequent updates there. On the other hand, if it is question answer and dialogue kind of thing, so this data will be data, but the knowledge to extract the answer, as long as that part we are very confident about, we need not retrain the system that frequently. So if you even budgets and other things, those will happen once a year. But yeah, there are situations where every single microsecond data may change. So periodic retraining, I think these kind of systems will not be retrained very often. Yeah. So even if you look at many of the large LLMs, I think the total training time depend on multiple factors: number of tokens that you have in your vocabulary, the embedding size, then yeah, of course, the instances, number of training instances would be there, and also your hardware. So there are systems, even the best of the systems will be trained for 21 days, 30 days, and so on. So yeah, maybe they'll invest on that once a year or something like that. So with this, people are also talking about green NLP or how to reduce the power consumption. There were many such studies which are coming up to, so for one single inference, what is the power that you are consuming? And can you equate that power consumption in some sense with the carbon emission and other things? And the numbers that they're quoting are actually very staggering. So even for, and that is happening even for inferencing, and training will be much more problematic.